Over to you, Linda.
Thank you, Francis. I hope my voice holds out for the session. I was just explaining I've had a flu this week, so I'll give it a go, but please accept my apologies if it doesn't. Good evening, everyone. As Francis said, today I'm going to be talking about some global trends and developments, but particularly in the area of SNOMED CT. So I'll give you a brief introduction to my background. I currently lead the new implementation support team at SNOMED International, and I'll tell you a bit more about that team later in the presentation. Previous to this role, I led the education team at SNOMED International, which delivers SNOMED education to around 80 countries. I actually come from a technology background. I have a degree and a PhD in information technology. I've worked for a range of technology companies in Australia and the US. And then when I moved into the eHealth space at the end of the 1990s, I then worked at the Australian eHealth Authority and then Singapore's Ministry of Health. And then in 2014, I started at SNOMED International, where I've been for around 8.5 years. My main specialty areas include clinical terminologies, drug dictionaries, EHR implementations, information modeling and data analytics. I'm the author of the expression constraint language, the expression template language, and I maintain SNOMED compositional grammar. And I've been involved in HL7 for many years, including the SIMI and HL7 SNOMED on Fire work. So that's me. And today I'm going to give you my perspective on some of the past trends we've seen in healthcare and terminology and some of the new areas that SNOMED International is focusing on at the moment. And I'll finish up with some links where you can discover more. But before we start, I'd like to give you a quick overview of SNOMED CT as a background to the rest of the presentation. So SNOMED CT stands for SNOMED Clinical Terms. It's the most comprehensive multilingual clinical terminology in the world, and it supports the effective recording, retrieval, and analysis of high-quality clinical data in health records. SNOMED is not just a coding system for diagnoses. It covers a broad scope of different clinical meanings that are relevant to clinical records. It also covers types of clinical findings like signs and symptoms. It includes surgical, therapeutic, and diagnostic procedures. It includes observations, body structures, organisms, substances, pharmaceutical products, and physical objects, physical forces, specimens, and many other different types of information that you would expect to see in a health record. The international edition of SNOMED CT is maintained and released by SNOMED International. We're a not-for-profit company based in the UK that's owned and funded by our 42 members, and we're governed by our General Assembly with representatives from each of our members and our management board. And as I'm sure you know, the Canadian edition of SNOMED CT is delivered by Canada Health Infoway, who serves as the National Release Centre for Canada. Here are the flags of our 42 members. Canada is obviously a member. And as you may be aware, Canada was one of the original 9 founding members back in 2007. Our most recent members include South Korea, Germany, United Arab Emirates, and Thailand. And France has also announced that they'll be joining this year. And there are quite a few other countries who are discussing joining at the moment as well. SNOMED CT is designed using 3 main components: the concepts, descriptions, and relationships. So firstly, a concept is a clinical idea that has a unique meaning and a unique identifier. So in this example, the doctor is imagining a myocardial infarction, which is a clinical concept identified using the code 2229806. Next, we have descriptions, which are human readable terms linked to a concept. Each concept has a fully specified name. In this case, it's myocardial infarction disorder. and at least one synonym, such as in this case, we've got cardiac infarction, heart attack, and some French synonyms as well. And then once the synonyms have been created, we use something called a language reference set to select which of the descriptions are preferred and acceptable in a particular dialect region or clinical setting. So this allows us to customize the way in which we refer to each clinical concept. The third type of component is the relationship, and some relationships are used to form the SNOMED hierarchy. So in this case, myocardial infarction has 4 more general parent concepts, and other relationships can express the defining characteristics of a concept. For example, a myocardial infarction has a finding site of myocardium structure and an associated morphology of infarct. And there are hundreds of different types of relationships like these that are used to define different characteristics of our clinical concepts. And a new kind of relationship was introduced last year, and I'll talk a bit more about this shortly, for defining characteristics using concrete values like numbers and strings. So here's a simple example that shows an amoxicillin 500 milligram tablet with 2 concrete value relationships. Firstly, it has a presentation strength numerator of 500, and it has a count of base of active ingredient of 1. So all of these different types of relationships, the hierarchical, the attribute, and the concrete value relationships, work together to form the logical definition of a concept, which can be automatically reasoned over using a description logic reasoner. So here's a diagram that shows the logical definition of the concept myocardial infarction with its 4 parents and its defining attributes. And here's the full definition of our amoxicillin 500 milligram oral tablet with its parent, its attribute relationships, and its concrete value relationships with the green concrete values. SNOMED also has a range of other features, including our machine-readable concept model, which provides the rules for authoring and querying clinical meaning. Our computable languages are used to create expressions, queries, and templates. We use reference sets to distribute subsets, maps, and language preferences. And as I mentioned, description logic provides the formal foundation for SNOMED's computational reasoning and powerful data analytics. SNOMED also has a broad domain coverage, which enables queries across different disciplines, specialties, and clinical areas. It has a robust versioning mechanism. It's international, which enables codes and derivatives to be shared, but it also has localization mechanisms to support customization at national, regional, and local levels. So that was a very quick overview of SNOMED CT, just to give you some background. So let's now talk about some of the past trends in eHealth. I'm sure you've all seen graphs like this that show a global trend of increasing healthcare costs. And this trend has certainly continued in the last few years through and beyond the COVID-19 pandemic. We've also seen an aging population around the world. And as the population ages, the prevalence of chronic disease has increased. And even before the recent pandemic, there was already a global trend showing an increasing number of infectious disease outbreaks and also an increasing variety of emerging diseases. And then obviously in early 2020, we saw COVID-19 have a huge impact on just about everything, from travel to education, business, technology, the environment, and of course, healthcare. And through all these challenges, it's become more and more important for governments and healthcare institutions to use the data that they're collecting in the best possible way. In order to make sense of the data, to integrate the data from different systems, to query the data in a meaningful way, we need standards like SNOMED CT. So this is a graph of the membership growth in SNOMED International from 2007, when the IHSDO was formed by its 9 founding members, through to today when we have 42 members and growing. And there are also currently over 30,000 institutions in non-member countries who have SNOMED affiliate licenses. And certainly over the last 10 years, there's been a significant trend towards increasing SNOMED implementation maturity, particularly the last few years. So this is our implementation maturity model. And back when I started at SNOMED International, most implementations were at level 0 to 2. So they were either not using SNOMED, but often had plans to, or they used other codes and just mapped to SNOMED at the back end, or they used SNOMED just like a flat list of codes. So this gave them standardized coding, which is useful, but they weren't really taking advantage of SNOMED's semantic features. So since then, we've seen a huge shift towards maturity levels 3 to 5. In level 3, systems are using SNOMED's hierarchy to search and aggregate data. They start to use the defining relationships in level 4. And then in level 5, they're really leveraging SNOMED as an ontology. So they're using our expression constraint language and other features made possible by our concept model and description logic definitions. So this increase in SNOMED implementation maturity, I think, is driven by a number of factors, including the increased availability of SNOMED education, but also the increased availability of SNOMED tools and terminology servers, which make SNOMED deployment much faster and easier. Also, the standardization of service interfaces like the HL7 FHIR Terminology Services API, which supports SNOMED queries and searches. So with this in mind, we're now going to explore some of SNOMED International's current and future focus areas for SNOMED CT. Now, I don't have time to talk about everything we're doing. There's obviously a lot going on at the moment, but from my perspective, the 3 main SNOMED focuses at the moment are, firstly, improving the quality and responsiveness of SNOMED itself. Then there's an increasing need for international collaboration, for standardized data sharing and for interoperability. And lastly, our CEO, Don Sweet, recently summed up the 3 most important things for our members at the moment as implementation, implementation, and implementation. So from here on in, I'm going to refer to this as implementation cubed. So let's start by talking about how we're improving the quality and responsiveness of SNOMED CT. There have been a number of recent initiatives in this area, including the efforts to increase the semantic expressivity of SNOMED, SNOMED International's Quality Improvement Initiative. We have moved to more frequent international releases, and we now provide a mechanism for more flexible delta generation. So before July 2019, SNOMED International used to author SNOMED concepts in terms of simple stated relationships. And then we started to model clinical definitions using description logic axioms. So this means that we can now express much richer semantic definitions than were previously possible. And therefore, when we pass these axiom definitions to our description logic reasoners, we're able to produce much more accurate inferences than ever before. And this in turn improves SNOMED's data analytics capabilities because queries are normally performed over these inferred relationships that are generated. Once the new stated axioms were introduced, we were then able to introduce concrete values in July of last year, as concrete values numbers are able to be represented very simply within the stated axioms. So this is a high-level overview of the old authoring process before July 2019. The authors used to create new concepts with descriptions and stated relationships, and these files would be converted into OWL and then passed to the classifier, which would generate the inferred relationship file that most implementers will use for querying. So now authors still create the concepts and descriptions, but they create these OWL axioms when they author a SNOMED concept. And this gives them the extra semantics that they can now represent. So these axioms get combined and classified, and the output, as of July last year, will be two files, the inferred relationship file and also the new concrete values file. So here's the diagram I showed you earlier of the inferred definition of amoxicillin 500 milligram oral tablet. So these are all the non-redundant relationships that are inferred by the description logic classifier, and the concrete values are shown in green. So these concrete values, now that we're storing them as numbers, as both integers and decimals, they can be processed using mathematical operators like multiplication and addition, and numeric comparisons like greater than or less than. So you can find the medications, for example, that have less than 500 milligrams of amoxicillin in them using these concrete value relationships. The next initiative, which focuses on improving the quality of SNOMED, is appropriately named the Quality Improvement Initiative. This is a multi-year project which began back in 2018, and it focuses on the quality and structural consistency within the terminology. SNOMED International uses a range of tools that allow us to combine automated expression templates together with manual authoring reviews to identify and fix modelling and naming inconsistencies. So the initial focus of this project was on the clinical finding hierarchy, with also some work on medications and substances, but we've now started on procedures. So our procedure work involves looking at all the different types of procedures, from computed tomography, bone grafts, and arthroscopies to analyse them and improve their modelling. You may have also heard about the Frequent Release Initiative. So historically, the international edition of SNOMED has been published every 6 months, every January and July since 2002. However, COVID-19 provided the perfect use case for why frequent releases can be important. So back in January 2020, the WHO declared the coronavirus outbreak a global public health emergency first. And so SNOMED International made sure that in the January 2020 release of SNOMED, we included the disease called disease caused by the 2019 novel coronavirus. But then in February of that year, the WHO announced the new official name of the disease was COVID-19. And they also released some new ICD-10 codes for this. So on March 9th of 2020, SNOMED International published its very first out-of-cycle release to update the COVID-19 descriptions and to add in maps to the new ICD-10 codes. But it was quite apparent that situations like this will continue to arise, and a rapid, flexible response from the terminology is needed. So on February 28th of this year, SNOMED International published its first regular monthly international release. The international edition is now published monthly on the last day of each month. So far this year, we've had international releases on January 31st, February 28th, March 31st, April 30th, and May the 31st. And the next release will go out at the end of June. So this allows the terminology to respond more quickly to important and necessary changes. It also provides our members with earlier access to the content that has been requested, either to allow them to get a jumpstart on translations or maps, or to actually use the new codes in their systems if they need to. It also gives our users and members more flexibility as to which release they wish to use. However, there's no extra obligation for users or members to use these more frequent releases. They're just there if you need them. So these regular international releases don't affect everyone. If you use the international edition directly, or you maintain a national extension that's directly based on the international edition, then you get access to the more frequent international releases if you want them. However, if you're using a national or a local edition of SNOMED CT, like the Canadian edition, then you will still use the release cycle of the edition that you're using. So, for example, systems which are directly using the international edition, they can choose to take advantage of these more frequent monthly releases and update their systems in, say, January, April, July, October, or whenever works best for them. And if you use a national edition or a local edition, you will keep your system up to date based on the release cycle of that edition. So the frequency of the releases really depends on which SNOMED edition you're using. But as I said, users of the international edition are not expected to upgrade to each monthly release. But this introduces increasing flexibility as to which releases you can use in your system. And therefore, the changes you need to upgrade your system will depend on which version you're upgrading from. So SNOMED International has introduced a new flexible approach to generating Delta files where you can customize the Delta file between any two versions of SNOMED CT using an open source Delta generation tool, which is now available on GitHub. So our second focus area is the need for standardized international data sharing. The initiatives I'm going to talk about in this area are the Global Patient Set, or the GPS, the new International Patient Summary Terminology, or IPST, the Common Drug Model for International Interoperability, and our community content platform. So firstly, you may have heard about SNOMED International's Global Patient Set, or GPS, which was launched back in 2019. This is a managed collection of SNOMED CT codes, which is made available to all users at no cost to support the international sharing of health information across national borders between both SNOMED members and non-member countries without needing to worry about licensing issues. However, the GPS only includes concept identifiers and their US preferred terms, and it does not include the hierarchy or any relationships. So the next evolution of this free set is specifically designed to support the sharing of the International Patient Summary data. The International Patient Summary, or IPS, is a minimal set of basic clinical data about a patient that's used to support cross-border or cross-information system patient care. It was defined by ISO and CEN and has been represented by HL7 in both CDA and FHIR. And so to support the interoperability of IPS data, SNOMED International has developed a new product called the IPS terminology. The IPS terminology takes the free IPS-related content from the GPS and publishes it as a sub-ontology. So it's designed for users who don't have an affiliate SNOMED license, so they're in non-member countries, to use in their IPS implementations. So what does a sub-ontology mean? What that means is that the IPS terminology, it includes the hierarchy and the defining relationships for each of the concepts in the IPS free set. It's published in the RF2 release format, so it can be loaded onto a terminology server. And that means you can query it in the same way you can query a full edition of SNOMED using the ECL query language. The IPS terminology is currently available as a beta. You can request it by emailing releases@snomed.org, or you can browse it at ipsbrowser.snomedtools.org. And there's a user guide here at snomed.org/IPSTUG that explains how to use it in a system. So one of the clinical areas included in the International Patient Summary is the patient's medication data. And given that there are many different national and local drug dictionaries around, SNOMED provides a mechanism to make these more interoperable. SNOMED has a common drug model for both the drug content in the international edition and also drug content in a national extension. So the international drug model represents clinical drugs in terms of their ingredients, strength, and dose form. And then the national drug extension models can add in the brand names and the pack sizes available in that country. So the secret to the drug model's interoperability is that all drug concepts can be defined using common international building blocks. So this includes a set of common medication attributes, such as has precise active ingredient, has manufactured dose form, has product name, has pack size, etc. And also a set of common international attribute values. So the international substances, international dose forms, units of measure, and things like that. So if you're using the same attribute types and the same attribute values, then a description logic reasoner can automatically compare concepts from different drug dictionaries. It also allows you to use exactly the same queries across different drug dictionaries. So ideally, if you define a national drug dictionary as a formal SNOMED CT extension, this makes interoperability the easiest. But you can also use an existing national drug dictionary and just map this to the common drug model. The goal, of course, is to be able to support use cases such as cross-border patient care, in which you need a person's medication list to be computer processable at their destination. So you can find the common drug models at snomed.org/MPM for medicinal product model, and snomed.org/NDEM, which stands for National Drug Extension Model. And finally, for international data sharing, we've got our community content platform. This is a collaborative platform for sharing global content, which is outside the current scope of the international edition. This community content area already includes a number of extensions. For example, the Cancer Synoptic Reporting extension, the Common French Translation, the COVID-19 Vaccine Project, some genomics content, and the Traditional Medicines Project. And you can view each of these extensions through a SNOMED browser, and the plan is also to make these downloadable. So at the top of the slide, there's a link to the community content area if you'd like to take a look. So the last focus area for today is implementation, implementation, implementation. There are too many projects in this area to talk about all of them. So today I'm going to focus on these ones: our SNOMED CT value platform, our new implementation support team and portal, our free tool for mapping to SNOMED, new improved support for querying SNOMED codes in patient records, and the initiatives we're currently planning to simplify the deployment of terminology services. One of the early steps in an implementation is to understand the values that SNOMED CT can offer and develop a case for investment to secure the funds to drive the adoption and the implementation of SNOMED CT. So SNOMED International has developed a SNOMED CT value platform that presents stakeholder value propositions, a qualitative and quantitative case for investment, and also a set of exemplar case studies, which are fairly new to the platform if you've already had a look. So the value platform and the exemplar case studies cover a range of different types of implementation. all of which SNOMED CT is used, including clinical data entry and data integration systems, solutions that support the sharing of clinical information, point of care analytics, such as clinical reports, summaries and decision support, population analytics, such as trend analysis, pharmacovigilance and clinical audit, management analytics, which includes the analysis of health system value, and clinical and scientific research. And you can explore the SNOMED Value platform at www.value.snomed.org. So one of the big implementation initiatives from SNOMED International is the launch of our new implementation support team at the end of last year. Our mission is to provide assistance to national release centres, healthcare providers, research organisations and vendors in their adoption and implementation of SNOMED CT. We're a fairly small team, considering that we're supporting more than 42 countries, but it's an amazing team, if I may say so myself. And we're working collaboratively with each of the national release centres to identify our priorities to focus on. So in the team, we have myself, Alejandro Lopez Osornio, who is a general physician. He has significant experience with both SNOMED strategy and tooling. Kai Cooley, who was the lead architect and developer of our terminology server, Snowstorm, and Anna Hoyen, who has many years of experience in the SNOMED education team. To find our implementation support resources, the best place to start is our new implementation support portal, which you can find at snomed.org/support. The portal has 6 main areas. In the library, you can find a range of implementation frameworks, guidance documents and specifications. The training area explains our SNOMED courses and learning pathways. We run implementation workshops, which can be arranged through our customer relations team. Our tooling area is worth exploring for anyone interested in SNOMED tooling, because it explains all the different types of tools you may need to implement SNOMED CT, everything from browsers to mapping tools, from terminology services to user interfaces and natural language processing. And then for each type of tool, it explains the role, the typical functionality, and then we provide links to a range of open source and commercial tools available in that area. We have our user groups, so everything from our SNOMED on Fire group, our computable languages group, our mapping tool user group, our drug extension user group, our translation user group, our clinical reference groups. There's a whole range of user groups that you can get involved with if you're interested. And finally, our help desk. And as I said, snomed.org/support is where you find this. The next topic I wanted to talk about is mapping. So many SNOMED implementations start by mapping their existing local or proprietary codes to SNOMED CT. But to manage these maps effectively requires a tool that's able to manage the mapping process and also support the upgrade of the map to new versions of SNOMED CT. So SNOMED International has commissioned CSIRO in Australia to develop an online tool, which we call Snap to SNOMED, that supports the collaborative authoring, the review and maintenance of simple maps to SNOMED CT. Unfortunately, this isn't time to demonstrate the mapping tool to you today, but you can access the tool yourself at snap.snomedtools.org. You just need a free Confluence account, which you can access through that site, and you use that to log in. We've also added several demonstration videos to the user guide that you can find at snomed.org/S2SUG for user guide. And if you're wanting to find those demonstration videos, go to the user guide and have a look at the Quick Start guide in Chapter 2. And the Quick Start guide is where all of our demonstration videos are. Another thing we've done to improve SNOMED support for maps is to introduce some new map ref set types that is designed to support mapping from other code systems to SNOMED CT. So the original map ref set types that SNOMED International developed were really designed to support maps from SNOMED to other code systems like ICD-9, ICD-10, or ICD-0. So they were using the reference component ID for the source SNOMED concept, and then they'd use a field called map target for the target code in the other code system. And for years, we were trying to squeeze maps going in the other direction into this format by putting the map source into the map target field. But it got really confusing. And so recently, SNOMED International needed to publish our own maps from MedDRA to SNOMED CT. So we introduced a new set of map ref set types that have a map source instead of the map target, so that when you map from other code systems to SNOMED, you can put the map source from the other code system into the map source field and the map target from SNOMED into the reference component ID field. So hopefully that's a lot clearer for everyone. And if you'd like to see the new map ref set formats, you can go to our release file specification at snomed.org/RFS and visit chapter 5.2.3, which takes you into the ref sets and then the map ref set types in that specification. So one of the most significant benefits of using SNOMED CT is the power it gives you for querying codes in a patient record. So whether you're defining a clinical decision support trigger, whether you're defining the linkage conditions for knowledge resources, whether you're defining data entry rules, or if you're just querying a patient record for patient care, population health, or clinical research. All of these things can be done using a query over your health records combined with a query over your terminology. And SNOMED's query language is called ECL, or the expression constraint language. An expression constraint is a computable rule used to define a set of concepts or a set of clinical meanings. So here's an example that finds the descendants of clinical finding, which are also a member of the International Patient Summary ref set, and either have an associated morphology that's a type of infarct or are associated with a type of myocardial infarction. So you can find the ECL specification at snomed.org/ECL. So one of the implementation challenges that we've been working on over the last year relates to querying codes in patient records. So when you capture new clinical data in an electronic health record, it's good practice to only allow active SNOMED concept IDs to be recorded. However, SNOMED CT is an evolving terminology that needs to remain consistent with current clinical practice and our evolving understanding of disease processes and treatments and so on. So as a result, the terminology content changes. It might become outdated or need to be remodeled. And as SNOMED CT evolves, concepts that were previously recorded in the EHR may subsequently be inactivated. But it's important to retain the original concept ID that was recorded in the patient record, even if it's been inactivated. So this means that the number of inactive SNOMED IDs in your patient records can increase over time. Now, typically, an ECL query will return a set of active SNOMED CT concept IDs. So it hasn't been easy or even possible to retrieve health records containing inactive identifiers. And given that SNOMED typically improves over time, we wanted a solution that uses the most recent version of SNOMED CT. So this is where ECL version 2.0 comes in. The solution that we developed was to introduce what we call history supplements. This is where the active results of a query are augmented with relevant inactive concepts. And this is made possible because when a SNOMED CT concept is inactivated, the author allocates an appropriate reason for the inactivation and also links the inactivated concept to one or more replacements using historical associations. So in ECL version 2, we're using these historical associations to supplement the active concepts in the query results with inactive concepts, which are linked via these historical associations to the active results. So this now allows us to retrieve a more complete set of matching health records, including ones that contain SNOMED codes that have been inactivated. This, we believe, is a huge step forward in managing the implementation challenges of using an evolving terminology. So to help you understand how this works, I'm going to do a really quick demo of a development version of our SNOMED International browser. This version of the browser uses ECL 2.0. It's not available at the moment in the international browser, but it's due for deployment around Thursday of next week. So at the moment, you will see in our browser that it says, I'll show you, imagine this is browser.ihtstotools.org. And when you click on the expression constraint queries tab, in the current browser, you'll see that it's ECL version 1.3 or 1.4. So from Thursday next week, as soon as you see that this turns to ECL version 2.0, you'll know that these changes have been deployed and you'll be able to play with these features that I'm explaining to you now. So you just need to wait till next week. So the example I'm going to show you is for descendants of asthma. There is an ECL builder, if you're interested in having a look, which uses the machine readable concept model to help you build your ECL. But because I'm trying to be quick today, I'm just going to put less than, which means descendants or self of search for asthma, and I'll drag it across. So this defines the descendants and self of asthma. I'll click on execute, and it will show me that there are 104 results. And you will see that all of these results are active concepts. I'll just click on the extra 4. They're all active concepts, and they're all subtypes of asthma. So things like oral steroid-dependent asthma. So these history supplements are added. In this case, I'm going to say brace plus history, and we have 3 profiles: history min, history mod, and history max. And each one of them includes an increasing number of different types of historical associations. You can go to the ECL spec for all the details. I'm going to start with history min, which only uses the same as historical association. So we see there's now 133 concepts brought back. And if we scroll down the bottom and look at the second 100, we'll see that not only are the active concepts brought back, but we also have some inactive concepts. And I'm going to click on one of these inactive concepts just to show you in the ref sets tab that there is a same as historical association to the active concept acute asthma. And it's this historical association that caused this concept to be found. If we try min history mod, this will also include the extra possibly equivalent to historical associations. So we'll see that there's 151 concepts brought back. And if we include history max or just plus history, it will use all of the historical associations, and we see we've got 179. And if we scroll down and have a look, you'll see different types of historical associations on those inactive concepts that have been brought back. So that was a really quick demo, but as I said, this will be available for everyone from the end of next week at browser.ihtstotools.org or snomed.org/browser. There are also a range of other new features added to our query language, which you can play with in the browser from the end of next week. They include member filters, which allow you to select different columns of a reference set and filter rows based on the values of any of the fields and their properties. So this is really handy for filtering and bringing back map values, for example. You can also use the concept filters to query results based on their the concept RF2 properties, like the definition status. and description filters allow you to filter the results based on the properties of the descriptions of the associated concepts. So there's just a few examples that you can play with once ECL 2.0 is launched next week. One of the most important tools driving the adoption and maturity of SNOMED implementation is terminology services. These provide a rapid and effective way of deploying SNOMED CT because they provide the functionality to search SNOMED, to retrieve data, to run ECL queries, and to access maps, all pretty much out of the box once you've loaded the SNOMED edition that you're working with. The other really important development is the standardization of the interfaces to these terminology services via the HL7 FHIR Terminology Services API. So this allows you to swap the terminology server that you're using without changing your code. And there are now several open source and commercial terminology services to choose from that are SNOMED enabled. SNOMED International's open source terminology server that we use for our authoring platform in our browser is called Snowstorm. This is a great way to get started with terminology services because firstly it's free, but also developers can stand up their own SNOMED FHIR terminology server in less than an hour. And here's a URL where you can download Snowstorm from, and also a user interface demo that uses Snowstorm in a user interface just to show you what can be done. And because of how important terminology services are in the efficient implementation of SNOMED, we have a number of terminology services projects planned over the next 12 months. We're currently adding support for multiple code systems in Snowstorm. So not only will you be able to deploy SNOMED CT, but you'll also be able to add ICD-10 and LOINC and any other code system that you're using. We're aiming to have this deployed by September, but certainly by the end of the year. The other project we'll be working on is the Simple Extension Toolkit, or Simplex Toolkit for short. This tool will allow you to publish and maintain your SNOMED derivatives. So that's maps, translations, and subsets of SNOMED, and then deploy them on a terminology server of your choice. So it will publish these maps, translations, and subsets in our RF2 format so that they can be loaded onto a terminology server. It will help to manage changes between releases, including the inactivation of any members of a ref set that are removed and things like that. It will also help to find inactive codes in your derivatives and suggest alternatives based on the relevant historical associations. We're also planning a Snowstorm dashboard to provide a more friendly user interface for deploying Snowstorm terminology servers. And we're planning to add support for post-coordination to Snowstorm, to the FHIR APIs, and to develop a post-coordination guide to explain how to use post-coordination with FHIR and terminology services. And lastly, we're planning to develop a syndication service, which will allow you to subscribe for automatic updates to the terminology content on your local terminology server. So all these initiatives are planned, and hopefully, if I'm back in 12 months, I'll be able to tell you more about each of these. Before we finish, I'd like to quickly mention a few resources from SNOMED International to help you learn more about SNOMED CT. There are a range of different ways you can learn, explore, ask, and participate in the international SNOMED community. We have a range of courses in our course catalogue, which are free to everyone in Canada. We've very recently, I think the last few days or weeks, launched a brand new foundation course. Our implementation course is now self-paced, so you can start at any time. And we also have a terminology services course and several others. I mentioned our implementation support portal, but one of the pages on that portal, which may be useful to some people, is snomed.org/links. And this includes all of our popular SNOMED links all on one page. So snomed.org/links is a really useful resource. You can ask questions via our help desk. We have a public Slack channel, and also developers can ask questions through our GitHub repositories. There are a range of user groups to participate in, and to see a calendar of all the meetings that you as a member of the community can join, you can visit snomed.org/WOTW, which stands for What's On This Week, WOTW. And please mark your calendars for September 29th to 30th. This is our annual SNOMED CT Expo. Our event this year is going to be a hybrid event. You can either join us in Lisbon, Portugal in person, or connect online. And to find out more, visit snomedexpo.org. Thank you very much, everyone. Are there any questions?
Well, first of all, thank you, Linda, for the wonderful presentation. I'm going to stop the recording.